Hi, everybody. Thanks for joining us today. I have an intro to do before we get started, and I just wanted to go through that with you first. Thank you for joining us for the second webinar of 2025. My name is Jenny Novak, and I'm the marketing manager here, and I help coordinate the webinars. Welcome back if you joined us for webinars in the past. And if this is your first one, thanks for being here. We have a pretty good turnout today. A lot of people registered. A quick intro about us. Dyne is an independent testing laboratory that's been testing firefighting foam for over 25 years. We also test antifreeze, dry chemical agents, and sprinklers, if any of you have been on those webinars. Last year, we were acquired by NFPA Global Solutions, and as you might have noticed, we've been doing some rebranding, while we've continued to provide the same fast, reliable service and quality test results. We're always asked if we're certified or accredited. Dyne is ISO 9001 certified, and we also have a 17025 accreditation by A2LA for our automatic field sprinkler testing. Just a little bit of housekeeping before we get started. If you have any questions during the presentation, you can type them into the chat panel. We usually save up the questions along the way for a Q&A session at the end. And once Alyssa and everyone has presented the content of the webinar, if you stay to the end of the webinar, you will receive a certificate of attendance for today. Some people use our webinars for things like NISEP credits. This webinar is also being recorded, and you'll receive a link to the video that we published on our Dyne YouTube channel. Today's webinar, Firefighting Foam Testing, will be presented by Alyssa Dunn, who is the General Manager here at Dyne. She has extensive knowledge in firefighting foam, sprinklers, dry chemical agent testing, and antifreeze, as well as the NFPA 25 requirements. Alyssa has over 7 years here with Dyne, and she previously served as a lab tech, lab supervisor, and manager before becoming our general manager in 2025. Following Alyssa, if we can get connected, I think we're connected. We have special guests with us today, Beryl, the director of the analytical lab at Claros Technologies, and Andrew Christensen, who is the CEO of Novum Scientific. So thank you to them for joining us today. And now let's get started. I'll turn it over to Alyssa to talk to us about firefighting foam testing.
Thank you so much, Jenny. Before we get started, let's see. Oh, my slides. There we go. Before we get started, I just want to put a disclaimer out there that this presentation is my opinion. So any opinion expressed in it is the opinion of myself and does not necessarily represent the official position of NFPA or its technical committees. So we're talking about firefighting foam today. The big question is, why do we need to test it? Right here on the slide, you can see of a wide variety of foam samples in jars, a wide variety of colors as well. Oftentimes you put your foam into service, you put it in a system and hope you never have to use it. But when it does need to be used, you want to make sure that that foam is capable of performing as intended. But looking at the foam itself, you can't do that. A visual inspection is not enough to verify that the foam is going to perform as it was listed to perform. Even there's different products out there that have specific colors. Colors can change over time as the foam is exposed to the environment or different storage conditions. The colors can change. So a visual representation of a foam is not a good check on verifying whether it's going to perform as intended. So visual inspection is not enough, which is why NFPA requires annual testing. Not sure where my slides are. Here we go. Okay. So NFPA 25 does require testing to be conducted annually for foam concentrate. That is in NFPA 25 11311. And then the following section says that you need to send in your foam samples to the manufacturer or an approved testing laboratory for quality condition testing. I will say that these references are from the newest edition of NFPA 25, so the 2023 edition. If your state is incorporating a different standard by reference, you may have slightly different reference numbers, but by and large, the content should be the same. It hasn't changed over the last few editions. If you're referencing an older edition, you may be familiar with NFPA 11. The testing requirements used to be housed in NFPA 11, but in the 2024 edition of NFPA 11, they moved the requirements into 2023 edition of 25. So I think in NFPA 11, I think it's chapter 13, there's just a single line in there that says reference NFPA 25. So the requirements hasn't changed. You just may be more familiar with different standard or reference numbers. As far as sending in your samples for testing, again, a visual representation isn't enough. So you do need to send it in to be tested for quality condition testing, and you should send it in to a manufacturer and approved testing laboratory. As far as what is an approved testing laboratory, NFPA doesn't really define what that is. They also don't approve testing laboratories themselves. In the annex of the standard, you can find an explanation as far as what they mean by approved testing laboratory. Essentially, it just means that it's acceptable to the authority having jurisdiction. So your AHJ really should be the person deciding who is an approved testing laboratory. I will say that we've never had an issue with our reports not being approved by an AHJ, but it is ultimately up to them to decide whether the report or the laboratory is acceptable to perform this testing. So again, you send it into a laboratory. We need to do quality condition testing. What is quality condition testing? What does that mean? NFPA also doesn't define specifically what foam quality is. In general, we can look at other standards, other listing standards out there, and most tend to agree that quality can be evaluated by two main things: the expansion ratio and the drain time. So the expansion ratio, we're looking at the nice foam blanket that is made. So if you have 3% foam concentrate, you have 3% foam and then 97% water. Mix that together and, discharge that, and you have this nice foam blanket with bubbles. You've probably seen that in this picture here. It's a very small scale, but this graduated cylinder, these bubbles here represent the foam blanket. And depending on the product, you're going to have different requirements for the expansion ratio. So like a low expansion product, you'll probably have, anywhere from like 5:1 to 10:1 expansion ratio. And different products are going to have different requirements. If you have a high expansion foam, you're looking at more like 1,000:1 expansion ratio. And then the drain time. So it's great if your product makes a nice foam blanket, but if it just immediately dissolves back into solution, if those bubbles just immediately pop and drain back into solution, that's not great for performance. Then you're just going to keep using foam and it's just going to continue to dissolve. It's not going to be very effective. So you do want to measure the drain time. In the cylinder here, the liquid at the bottom of the cylinder would be the foam blanket that has dissolved back into solution. And it's measured by the 25% drain time to kind of save time and not wait for the whole foam solution to drain back into a solution. We just measure 25% by mass. And again, different products are going to have different requirements. And if you're looking at a high expansion product, typically we evaluate the 50% by mass drain time instead of just 25%. But that is essentially what foam quality is. We're looking at the expansion ratio and the 25% drain time. Now, if you send it to a lab, they're also likely going to do some other testing. Instead of, we're not just looking at expansion ratio and drain time, there's some other things that they will measure as well, and Dyne does as well. Right here, refractive index, density, viscosity, pH. These are going to be physical properties. And essentially what we're doing is comparing the foam to, when it was first manufactured or first listed. When you first purchased it, ideally you would know the product you have so that we can reference, the refractive index, the density, the viscosity, the pH, from the original data sheet. If you have a sample that's been contaminated or degraded or diluted with water, dilution with water specifically, you're going to see your refractive index and density drop, and that will likely be reflected in the performance properties as well. So if it's diluted enough, you're going to see a drop in the performance properties, and the expansion ratio and drain time will likely fail as well. So It won't necessarily fail for having a refractive index or density that's too low, but eventually you're going to get to a point where it starts to impact the performance. So it's just important to measure these. And if you're really on top of it, you can track it over time and look at your report and how your samples age over time. Viscosity is going to be important as well. Typically, if you have a standard AFFF, those products are typically thin. They don't really have much of viscosity at all. So you likely won't see that on your report if you have an AFFF. But if you have an alcohol-resistant product, an ARAFFF, those typically have a polymer in them that make them thicker. They make them alcohol-resistant, so you can protect against polar solvents, depending on what you're using your foam for. And that viscosity is important because you ideally don't want it to change too much over time. If your sample gets diluted, you may see that viscosity drop, and that could be a problem for performance. It may not be able to perform as it was intended or protect against polar solvents as well. And you also may start to see issues with your proportioner. If the viscosity drops too low, your proportioner is listed and intended to be used with a certain product. And if that viscosity drops too low, you may end up putting too much foam on the fire, or a solution that's too rich, and you may run out of foam because you're pumping too much foam through the proportioner. On the other hand, if the viscosity increases over time, which can happen if if your storage conditions, if you're exposed to high temperatures and the foam concentrate, which is largely water, I think it's like 70 to 80% water in the foam concentrate, that water starts to evaporate, and then your foam kind of gums up and it gets thicker. And if that viscosity increases too much, you're going to have a problem where your proportioner may not be able to proportion at the correct percent. So your solution isn't mixed properly, and you may not have, the correct solution being discharged in the event of a fire. So that viscosity is an important one to measure and track over time. I will say there's the new products on the market, the SFFF, synthetic fluorine-free foam. I've also seen NFF, non-fluorinated foam, or even F3, fluorine-free foam. Lots of acronyms out there. Those products, even if they're not alcohol resistant, typically have a viscosity associated with them. And so that viscosity is important to measure for those products as well. Typically with the AFFF products, viscosity was kind of a measure of alcohol resistance. With these newer products, viscosity doesn't necessarily correlate directly to alcohol resistance. So for those products, you may, need to do some additional testing to verify alcohol resistance if that's the intent. But viscosity is important for all products, ARAFFF, and even the newer products on the market as well. And then finally, the film formation. So AFFFs, aqueous film forming foams, do have a secondary layer of protection. They form a film in addition to the foam blanket. So on this picture over here, on the top picture, this white section is like the foam blanket, and then you can kind of see there's a film that's formed over the fuel as well. So AFFFs do have that secondary layer. They have PFAS in them, fluorosurfactants that drop the surface tension of the solution and allow that film to form over the fuel. The synthetic fluorine-free foams, SFFF, don't have that property. They typically then just require a higher expansion ratio since they don't have that secondary layer of protection. We say spreading coefficient, in addition to film formation, because technically the definition of a film forming foam is it has a positive spreading coefficient. What is a spreading coefficient? Essentially, over here on the bottom here, we're measuring the surface tension of a foam solution. So to determine the spreading coefficient, you'd measure the surface tension like so. You'd also measure the interfacial tension between the foam solution and cyclohexane. And then you'd subtract those two values from the surface tension of cyclohexane to obtain your spreading coefficient value. So NSTA defines a film forming foam as needing to require a positive spreading coefficient. So if it passes this little Petri dish test, it forms a film in this Petri dish over the fuel, then we know for sure it has a positive spreading coefficient. So on your report, you may just see greater than 0. If it doesn't form a film in this Petri dish test, we would then determine the exact spreading coefficient value to be able to pass fail on the film formation properties. All right, so then NFPA 25 doesn't give a whole lot of requirements for the foam testing as far as specific values to test for. They do say when the foam type and brand of foam are known, quality testing shall confirm that product meets manufacturer specifications. So ideally, you would know the product that you have. It's in your best interest to know that, because then we can compare your sample with the product data sheet. So this is just an example here of a product data sheet. These are the typical properties associated with this product. So if we have this product in the lab, we receive it in for testing, we would compare these values to your sample. So ideally your sample would have, you know, a density and refractive and pH within these ranges. If it doesn't, that could mean a few different things. It could mean that the sample is contaminated or diluted or degraded. It could also mean that the product is a different one than specified. Sometimes people have the incorrect product specified when they send in their samples for testing. But ideally, you would know what it is so we can compare to these. Now, oftentimes you won't see the expansion ratio and drain time requirement listed on the product data sheet. Oftentimes, the laboratory, like ourselves, we will contact the manufacturer directly to obtain that information. Even if you do find that information listed on the data sheet, they don't always provide the method or equipment used. So it's not always a direct comparison to the method that we're using in our lab. So oftentimes we will have to contact the manufacturer directly to get those requirements. Now, if you don't know the product that you have, or we don't have specific expansion ratio and drain time requirements from the manufacturer, we do look to other standards to obtain some generic requirements. Like the mil-spec standard provides some generic requirements for testing. So we can test products. If you don't know the exact product, you at least need to know the type and percentage that you have. And then based on that, we can apply some generic requirements to those samples. Again, ideally you would know what it is, because there are some products that have, you know, lower expansion ratio requirements. So they may fail according to a generic requirement, but your product specifically may be proven to work at a lower expansion ratio and drain time. So it is important to know the product, but again, if you don't know for sure, there are ways around it. So then this is an example of our test report. In this example, we do have a specific product listed. So you are able to see some specific requirements on the test report. This top section here, the physical properties. Typically, samples aren't going to fail for the physical properties. You'll just see in spec and out of spec information listed on the results section. For appearance, it is information only. It's really just a good indication of whether you have the correct product or not, or it can be at least. If the requirement on the data sheet says the product should be a viscous yellow liquid, but then your test value is like a viscous purple liquid, you know, maybe you have a different product than what you've indicated, or you have something else going on. But appearance is just information only. We're not going to pass fail based on that. Refractive index, density, viscosity, pH. In this example, we have values that are all within the ranges here. So those are all listed as in spec in this column over here. If you have some values that are out of spec, that's not necessarily the end of the world. They could be just slightly on the edge of the range, and then they're listed as out of spec over here. But if all of them are out of spec, that could be an indication that you have something going on. Maybe if these are all on the low end, they're low, maybe you have dilution in your sample. You'll likely see that impacted in the performance properties. If they're all on the high end or just kind of outside of the ranges completely, it might be just a case of a different product than specified. Because again, you have to tell us what the product is, and then we can have these requirements listed on the report. So if you tell us what the wrong product is, then, you know, then they might not match up entirely. And then down here is the performance properties. So again, we talked about expansion ratio and drain time as being generally the requirements for foam quality. So in this case, the sample has a 4.5 minimum expansion ratio. This sample is obviously well above that, so that would be a pass. And then the 25% drain time requirement. This sample is a 3x3 ARAFFF, so it does have a 6.5 minute drain time requirement. If you had just an AFFF, you'd likely see a lower requirement there, like 2.5 minutes. Because this sample is an alcohol resistant product, it typically has that polymer in it. It does have a longer drain time requirement. Different products are going to have different requirements. I know there's some of the FFF products out there have a 20-minute drain time requirement, so much longer. Again, those samples do not have the film formation requirements, so they typically do require a higher expansion ratio and a higher drain time just because they don't have that secondary layer of protection. And then this film information down here. So I kind of mentioned this. So this sample did form a film in that little Petri dish test. So then we know it has a positive spreading coefficient. So you just see it listed greater than 0 on the test report. If you saw a partial film or no film here, then we would determine the spreading coefficient exactly. So you would see a number listed here, and then we'd be able to evaluate pass fail on whether or not that number is positive or negative. And again, sometimes people are just interested in the overall result. So if you look at your report and you just see overall result is pass, you don't necessarily need to look at all the details, but it is interesting, and it is, I think, important to look at your sample from year to year. If you have a test report in front of you and you have questions about it, feel free to give us a call or email us. We'll be happy to walk through that with you and answer any questions that you do have. All right, so NFPA doesn't specifically tell you how many samples you need to take from your tank. You know, like for sprinklers, they're very specific about, you know, how many you need to send for your sample area. Foam is a little bit more vague. Personally, I would recommend, if you have a very large tank, I would recommend taking multiple samples. You want to make sure that the samples that you send us are representative of what's in the tank. So if you have, you know, some trim piping that you're taking the sample from, you want to make sure that you drain that out before you collect the sample, because that foam in the trim pipe is going to be exposed to the environment, and it's likely degraded much more than the foam in the tank. It's not really representative of what's in the whole tank. You want to make sure you're taking a proper sample. And again, if you have a large tank that you've topped off multiple times, you know, the top of that tank may be in a different condition than the bottom of that tank. So I would personally recommend taking multiple samples, especially if you have a large tank. We are available to help you with that if you have questions. We do offer a 2-bottle kit and a 4-bottle kit. So if you have, you know, just one tank and you want to take a top and a bottom sample, the 2-bottle kit is perfect for you. If you just have one sample that you want to take, that's great. You can just fill it up and then put the empty kit in the box and ship it back to us. We'll recycle it into a new kit. If you have many samples that you're taking, the 4-bottle kit would probably be a better idea for you. If you're in need of kits, you can go ahead and request them online at dineusa.com. You can email our lab, or you can give us a call. We'll be happy to ship those kits out to you for your testing needs. I know we've been talking a little bit about, you know, the AFFF and synthetic fluorine-free products, some of the testing differences. I just want to say we are still testing AFFF products. So if you have AFFF systems that you're servicing, we still are testing those samples. And then once we receive your samples for testing, we do guarantee a 5 business day turnaround. So you'll get a confirmation email once we receive your samples, and then you'll have results in your inbox within 5 business days. Again, the kits are free, and we do include shipping within the continental US. So we try to make it easy for you to submit your samples for testing. If you're outside the continental US, then you do have to pay for the return shipping, but we will still provide you kits to make it easy for you. You guys can go ahead and start submitting questions if you have them. We'll do the Q&A at the end, but you can go ahead and start submitting questions if you have any. Jenny, I'll turn it back to you.
Thank you, Alyssa, for presenting all that information to us. Our next portion of our webinar is going to be done by one of our special guests. So I'd like to introduce the Director of Analytical Lab at Claros Technologies for some information on the PFAS. Beryl holds a PhD in chemistry from the University of California, Berkeley. Her expertise includes the analytical method development and chemical analysis via mass spectrometry. Beryl serves as the lead scientist for the Claros, supporting product development and conducting routine analysis for environmental clients. So it looks like we are all connected, and she's going to get her slides loaded up here, and then we will turn it over to her for her portion. It looks like we do have some questions coming through. Thanks for those. Keep them coming. We'll save them all up for the end, and we'll stay with you even past the hour a little bit if needed to answer those.
Okay, thank you, thank you, Jenny, for the introduction. Is my slide up? Sorry,
so.
That's a very silly question. Hi.
Looks like it's in your viewer, yeah.
Okay. It's not in the shared mode. Oh, here it
I
is.
think you're hitting the button right now. Now it is.
Okay, perfect. Well, thank you for having me today on the webinar. I'm gonna focusing on one very specific type of testing in firefighting equipment and firefighting foam. That's the PFAS testing. And PFAS has been quite a hot topic for a couple of years at this point. Oftentimes it is associated with the name of forever chemicals. You might heard the PFAS has been everywhere. There's PFAS regulation coming up. The last year finally has a drinking water regulation on PFAS. And there are a lot of people facing, a lot of companies facing potential liabilities when it comes to PFAS. So today's webinar, I will do a brief introduction of what is PFAS, why everybody cares about PFAS, and we'll move to some regulation about PFAS when it comes to firefighting community. And then we'll move to a very brief introduction of PFAS testing and show some data on the different type of testing. And we will end with some consideration when you are thinking about PFAS testing or when you're talking to a lab when you request for PFAS testing. So first, what is PFAS? It stands for per and polyfluoroalkyl substances. It is a whole class of chemicals. It is not a single chemical. And it features one of the strongest covalent bond that occurs, that is the carbon-fluorine bond. The current EPA COMTOX list has over 14,000 PFAS structures in that database. PFAS, most of them are man-made. There are a few so-called PFAS naturally occurs near volcanoes, but majority of PFAS are human-made, and they are synthesized or made or invented because it's water repellent and oil repellent nature. Such as, therefore, PFAS is useful, such as firefighting foam, equipment, and you can also probably heard PFAS being used for non-sticky cooking wares or some of the outdoor clothing that you can buy off shelf. Here I show some PFAS structure. Sorry, give me a second here. PFOA, one of the most popular PFAS that people probably heard. HFPODA here, this is often referred as GenX, and 62FTS, I showed this one here because this one is often found in a AFFF scenario. PFAS is environmentally persistent because it is not naturally degradable by bacteria, viruses, or any microbes. even they are able to digest PFAS, it takes years or hundreds of years. As a result, PFAS is circulating in our environment. You can find PFAS in water, you can find PFAS in soil, you can find PFAS in even vegetables grown on contaminated soil. And the PFAS has potential toxic influence on human beings. There are studies show that PFAS can cause cancer, cause birth defects, and there are also studies show that PFAS reduce immune system response when you have a vaccine. Instead of normal immune response, your immune response might reduce if you have elevated PFAS in your body. Oh, sorry. Before we go into regulation, I want to touch on the common units used when it comes to PFAS measurement. You might heard the parts per trillion and parts per billion already in a different setting. PFAS oftentimes is measured in parts per trillion and parts per billion. And parts per trillion stands for one parts per trillion is 1 nanogram per liter in aqueous, or 1 nanogram per kilogram in solid. And 1 parts per billion equals 1,000 parts per trillion. So it's just 1 nanogram per mil or 1 nanogram per gram. 1 parts per trillion equivalent to 1 drop of water in 20 Olympic-sized swimming pools. So 1 parts per trillion is very, very small. I also today be reminded that the community might be a little bit tired of this analogy. The other analogy is 1 parts per trillion equals about 1 second in 32 years. That's how small 1 parts per trillion is. And EPA drinking water for PFOA, PFOS, maximum contamination level is 4 parts per trillion, just for reference. Now, when it comes to firefighting community, what kind of regulations are there? The federal one is the biggest one is the National Defense Authorization Act, which phased out the use of AFFF with some exceptions by last year, actually October 1st, and forbids training exercise that will cause AFFF release. However, this federal level regulation only applies to military facilities or properties owned by the federal government. Among the states, each states are slightly different. On the right side, you can see a map that shows what kind of regulation each state has at what level. The black one shows the states that has regulation in multiple categories when it comes to AFFF. The orange one is focusing on use or discharge requirement. And the white one, those states has not quite catch up yet. The tan one is they have proposed regulation, but not quite there yet. By the way, this map, I got it earlier this year. That was updated last year, December. So this map might change a little bit at this point. Using Minnesota as example, no person shall or entity shall discharge AFFF for training purposes or for testing purposes, unless there is a proper containment, treatment, and disposal measurement to prevent release to the environment. And anybody discharge AFFF shall report it to the Minnesota Fire Incident Reporting System. And Minnesota also banned manufacturing or knowingly sell or use Class B firefighting foam contain PFAS chemicals with exceptions. How about other type of firefighting equipment? Thus far, there is no specific regulation when it comes to sprinkler systems. A few states, such as Connecticut and Massachusetts, have banned PFAS-containing firefighting gears. And the last one I want to highlight is a global regulation, which is published by the International Maritime Organization, which banned all ships from carrying foams that containing very specifically PFOS. And the list starts on January 1st, 2026. So to meet the requirement of regulation, of course, the first step is testing. And so when it comes to PFAS testing, there is two types of approach. One is the targeted approach, one is non-targeted approach in general. The difference pros and cons. I will start with targeted approach. Targeted approach is oftentimes you know which PFAS compound that you want to test for. For example, the maritime rule say the foam cannot contain any PFOS. So all you need to do is test for PFOS. And targeted approach has quite a few standard methods out there published by EPA, ASTM, and FDA even. And targeted approach covers all the PFAS compounds that US federal and states regulates. The downside of targeted approach is it only covers less than 1% of the total PFAS compounds out there. And from a lab standpoint of view, it is very hard to expand from existing method to cover more PFAS compound. Just give you a baseline here. For example, EPA's most comprehensive standard method out there is EPA 1633 for PFAS. It covers 40 PFAS compound. And to expand from 40 PFAS compound to say to 100 PFAS compound, it takes a lot of effort and resources. Therefore, targeted approach is not suitable for any blanket ban for PFAS. The non-targeted approach, on the flip end, analyze PFAS as a whole class. Instead of analyzing PFAS, the non-targeted approach oftentimes is analyzing fluorine that is bound to a carbon. Again, carbon-fluorine bond is the signature of PFAS compounds. Therefore, it is very suitable for any blanket bans on PFAS. However, the non-targeted approach does not reveal any information about specific PFAS compounds. Using the maritime regulation as an example again, non-targeted approach will not tell you how much PFOS you have in that foam. It will only tell you how much fluorine potentially binds to the carbon in that foam. There are some interferences, oftentimes is an issue in the non-targeted approach. But there is methods out there for non-targeted approach, such as adsorbable organofluorine, often refers to AOF, or you may heard EPA method 1621. There's total organofluorine, very similar to absorbable organofluorine, slightly different approach. There's extractable organofluorine. All that is considered non-targeted approach. Let me show you some data. So you understand the difference between the non-targeted and targeted approach. This is a sample I analyzed a long time ago. We analyzed this two samples. One is before filtration treatment and one is after filtration treatment, using both non-targeted approach and targeted approach. The targeted approach at that time was EPA draft method 1633. Again, this is way before EPA method 1633 finalized. And the non-targeted approach I used is the total organofluorine. Because the orange bar is from the targeted approach from EPA 1633. It shows about 1 ppm, less than 1 parts per million, total PFAS among the 40 compounds that EPA 1633 tested for. However, when we analyze it using TOF, we see 18 parts per million total PFAS. Or even after the filtration treatment, we see about 6 parts per million total organofluorine. So in this very specific case, right, the client sample is from a AFFF impacted waste stream. The target approach only covers less than 10% of the total PFAS. If you consider TOF shows the whole picture of total PFAS. On the flip end of using both approach is, this is the data collected by Claros Technologies. This is when Claros first started our UV-based destruction journey. So this is a super old data. It does not reflect the current Claros UV-based destruction performance. But at that time in the lab, we fortified a sample that contained PFOA, PFOS, PFBS, and PFBA with known concentration. We analyzed using LCMS. After destruction, we see most PFOA, PFOS, PFBS are gone. PFBA are gone, but we left PFBS largely not touched. And for the after destruction, we also subject that sample for total organofluorine analysis and free fluoride analysis. We see that total organofluorine is slightly higher than what we expected out of PFBS. That indicates that there is some incomplete carbon-fluorine bond cleavage from the PFOA, PFOS, and PFBA, but they are largely the carbon-fluorine bond are cleaved, and they form the free fluoride. So in using both approach, targeted and non-targeted, we were able to demonstrate over 80% defluorination for 3 compounds and 70% defluorination for total sample. Again, this is just an example to show you the differences of the approaches and how you possibly could use this. This way of using oftentimes referred as mass balance studies, which is considered holy grail when it comes to PFAS remediation. So last bit, I want to share some tips and tricks on when you consider PFAS testing, what to think about. When you're facing where do I start? Should I start with a targeted approach or should I start with a non-targeted approach? If you know what kind of specific PFAS you're dealing with, targeted approach is a way to go. If you're also facing potential liability against drinking water or maritime type of regulation, targeted approach is the way to go. However, if you are not even sure you have a PFAS problem, or if you are dealing with things that you like, okay, I'm not sure, where do I start? How much, what kind of level problem I potentially facing? Non-targeted approach is a good way to start because it tends to be slightly cheaper and less time consuming compared to targeted approach. If you are dealing with things such as mass balance, or you need to distinguish PFAS compound from fluorinated polymer, usually both approach are required to involve to kind of answer that type of question. Some question to consider, and I'm hoping that you had this discussion with whatever testing lab you choose to do PFAS analysis, is sampling and some of the testing requests. When it comes to sampling, something to think is your sample homogeneous or heterogeneous, right? As Elisa showed earlier, if you have a foam, right, you can have a aqueous layer and a more foamy layer. How do I sample that? Is the sample in a container, in a pipe? How do I grab sample, or do I mix them and somehow pull some sample out? How to avoid unnecessary contact with the sample, because nobody needs to be exposed to additional PFAS since the entire world population already exposed. And how to not introduce any unexpected contamination. That being said, for labs that deal with PFAS on a daily basis, I can tell you that contamination is the biggest issue when it comes to PFAS testing. And when you're talking to a lab about testing request, some of the question I think only you as a client can answer is, what is the question you try to answer here? You try to understand your PFAS problem, or you try to meet a regulation requirement, or do you have a lawyer knocking on your door? What question you try to answer here? What is the detection limit or quantitation limit you want to see? You will find a lot of regulation out there does not specify the quantitation limit, which leads to a lot of questions. And unfortunately, this is not a question any lab will answer you. You will have to consult with your legal counsel in many cases. Do you have a regulation compliance? What the regulation compliance requires? How much sample can you send to the lab? You know, a lot of EPA standard method has a minimum sample volume request, and they are like 250 mils, 500 mils. Do you even have 500 mils you can send? Sometimes is a question. And how fast would you like your results? And do you have special requests for reporting? Are you required to report to federal agency? Are you required to report to state agency? All these questions the lab hopefully will ask you. And this concludes my talk here. Here's some contact information. My contact information is right there. The TOF data I showed you is done by Novant Scientific and done by Andrew Christensen, and he is a panelist today, and his contact information is also listed here. And with that, I will pass it back to Jenny and Lisa.
Thank you so much, Beryl, for sharing that information. We appreciate you being here today. We're going to go ahead and take some time for questions, but I wanted to also introduce and include our other panelists we have today. Andrew, the CEO at Novum Scientific. He has a diverse background in the sciences that began with being head of research at a biotech startup. He's been providing sales and service of scientific equipment and applications to various industries. He's always been, his thing's always been helping other scientists in the pursuit of good data. And with all the knowledge he's acquired, he has the goal of wanting to help others. He saw a need for an independent laboratory that can do customized projects and can specialize in the total PFAS or total organic fluorine TOF testing. Thanks for being here, Andrew.
Thank you.
So I'm going to read off some questions, and we can kind of divide and conquer here with our questions if they're related to the foam testing we do here. Obviously, Alyssa can chime in. We might also have, I'm not sure if Grant's on the line, but any other questions on PFAS, we can also have you two chime in on answering those. So let's start with, our client requires a test within mainland America. Can you share details of the manager through whom this can be done?
I guess I don't know if you're looking for someone to take the samples. We don't really have any specific recommendations. We don't go out into the field and take samples. Your client could take the samples themselves and send it into our lab for testing. If you need, a contractor to go out and take the samples, I would just recommend looking up contractors or fire protection companies in the area that would be able to do that. That would be my recommendation.
Do you have an established date for the official phase out of AFFF in routine testing and training activity?
I'm not aware of a specific phase out date. I know, like Beryl said, that's not really, you shouldn't be using PFAS containing foam in any training environments. I don't have a specific phase out date for all the exceptions though.
Although we mentioned we're still working on doing the AFFF for now.
Mm-hmm.
The person's not looking for a brand or name of the company, but have Dyne found during testing any concentrate that clearly outperform or outlast other foam, or are they all pretty comparable?
I would say it totally depends on the storage conditions. Even a perfect foam stored in the really high heat outside is going to degrade, quickly. I don't have a specific recommendation. We see all sorts of different foams, and they're usually field samples. So I'm not sure, what type of environment they're stored in, but there's not one that specifically stands out. They're kind of all very comparable.
We have issues with customers that have many totes of foam and foam storage concentration tanks. They're generally good with sampling the concentrate tank. However, sometimes get pushed back on testing unopened totes or drums. We try to remind them that all should be tested annually. What is your guidance?
NFPA doesn't really define any guidance for that specific scenario. If they're all the same totes and they're all stored in the same environment, you could designate one to be your representative sample and just take from one tote. If they're stored in different conditions though, or they're different types of foam, then I would recommend testing the totes individually. But as soon as you open a tote, then it is open to the environment. So you kind of have to weigh the balance of testing all the totes versus, keeping them sealed. But I have seen that before, where if they're all stored in the same conditions with the same type of foam, they're the same age and everything, just designating one as a representative sample is a possibility. NFPA is vague in that requirement, so it's kind of up to you and the customer to determine what's best or what's most representative of your samples.
Can a foam sample quality test fail based on percentage of sediment in a concentrate? Or is this maybe noted as a recommendation for replacement?
I mean, on our test report specifically, if the samples are just tested to NFPA requirements, if we note that there is sediment present in the sample, there might be a comment on the report. If you have enough sediment in the sample, that may start to impact the performance of the foam. Its ability to mix well, or you might be getting more sediment than foam when you're mixing 3% and 97% water. If you're testing to IMO standards, the International Maritime Organization, there is a sediment test requirement for that standard, and I think it's 0.25% sediment is a requirement there. So for that standard specifically, then it would fail if it has too much sediment. Otherwise, if it's just NFPA requirements, enough sediment will start to impact the performance of the foam, and you may see a note on your report indicating that there was sediment present, but otherwise there's not going to be it won't fail specifically for having sediment.
Has data been captured that gives a good idea for what percentage of firefighting foam concentrate fails during test?
I think at Dine specifically, the failure rate is about 10% of foam samples that we've received. That's a very rough estimate. That's off the top of my head. But again, we receive a wide variety of samples, so I think that's a rough estimate of the percentage of failure rate for the foam samples we received.
I have a sample of water and foam mixture taken after the foam proportioner outlet. What tests are applicable for the sample?
So for that test, I would assume that you're going to want to verify the percent concentration of the solution. You want to verify that the foam is mixing at the correct percentage. That test you can do out in the field. If you have a conductivity meter or a field refractometer, you can verify the percent concentration in the field. We can also do that in the lab if you'd like. You send us a sample of the foam concentrate, the water, and the foam and water mixture. And we can tell you the percent concentration in the foam. As far as beyond that, typically you're just going to test the performance of the concentrate. If you mix up the solution and then try to send it in for performance testing, most concentrates aren't meant to be stored as solution, so that solution performance property is going to degrade very quickly. So that's not a representative sample of how the foam's going to perform. But I would assume you're talking about, verifying the percent concentration, which again, you can do in the field, or you can send it into our lab for testing to verify the percent concentration.
Thanks for that. What are some of the major differences that you're seeing between the FFF and the AFFF/ARAFF?
I guess I'm not totally sure what the question is asking. I know we talked a little bit about the differences in requirements. The SFFs are just going to have a higher expansion ratio requirement, and then they do have a significantly longer drain time compared to the AFFF samples. There's something to consider is the storage conditions and the life expectancy of the fluorine-free foams. Like Beryl mentioned, the AFFF products have PFAS in them. It's a forever chemical, so it makes the foam last a long time, which is great for performance, but not great for the environment. So those products tended to have like a 20 to 25 year life, shelf life, where the fluorine-free foams, since they don't have that PFAS in them, they may not last as long. So that's just something to keep in mind as well. I'm not sure if that answered the question. If you have a follow-up, just feel free to drop it in the chat.
Is there a requirement for annual testing, mil-spec in particular?
I believe it's annual. I know, mil-spec they might have different like performance requirements. I'm not aware of any other requirements. I can follow up, after the webinar. I'm not 100% sure on the requirements of that.
Will that include fluoride testing and foam samples?
No, we do not do any testing for fluoride or PFAS for foam samples. You'd have to send it into an external lab like Claros or Novum for those testing.
How big of a tank would you consider large foam tank, and what sample locations are required?
It's NFPA is vague on purpose, so that's kind of up to you. They don't specifically say that you have to take a certain number of samples depending on the tank of the size of the tank. I would say if you have like 1,000-gallon tank, if you think there's differences in the tank between the top and the bottom, if it's been topped off multiple times, I would definitely recommend taking multiple samples. As far as what the definition of a larger foam tank is, I don't have a specific definition, and NFPA doesn't either. They're kind of vague on purpose. You could just take one sample and that would meet the annual testing requirement. You just want to make sure that that sample is representative of what's in the whole tank. And that's why I say take multiple samples if you're not sure if you might have differences between the top and bottom if it's a larger tank. And again, larger tank is open for interpretation. So I apologize.
This might be a question for Beryl. You mentioned the PFAS destruction / cleaning, but do you also take into the account the rebound effect that seems to be prevalent with other cleaning solution methods?
Yes. So Claros, we don't do actual cleaning. There's other companies does the actual cleaning, the firefighting trucks, cleaning the tanks that was historically used for AFFF. Now they need to be moved to F3 foams, things like that. We are more on the destruction end, so we are more focusing on cleave the carbon-fluorine bond. They are unlikely to reform as naturally. So yes, I think when it comes to cleaning rebound, I have heard people have to do 5 rounds and multiple rounds of testing just to make sure there's no more PFAS leaking out after their cleaning effort.
For that. If anybody has any questions, feel free to type them in there. We have a few more minutes left. Someone did just quote one of the mill specs in here, a UFC number. We can also look it up and verify that and follow up with that after the webinar for specifics regarding that. Any other questions? And kind of give you, well, here comes one. Do you know in the future, foam sample tests include percent PFAS? I think we just covered that in another question, right? Future foam sample test includes percent. Not from dying.
I guess I'm not clear on the question. If you're just doing the annual, NFPA testing, there's no requirement in there for percent PFAS. There would probably likely be an external requirement that you're trying to meet that you would need to send into an additional laboratory for that testing.
Someone else is doubling up on the UFC and the number for that mill spec, and they use that frequently. So thanks for sharing with that. Sharing that, I can include that in my follow-up information. Someone else is wondering where else they can get more information on PFAS.
Depends on what kind of information you're trying to get. EPA website still have quite a bit information when it comes to PFAS. If you're more interested in very detailed, how do I do my test? Where do I even start thinking this? Feel free to contact me or Andrew from Novum Scientific here. We are happy to have another conversation to see whether we have the answers, very specific answer that you are looking for. each state, depends on which state you are at. If you are in Minnesota, Minnesota MPCA, Minnesota Pollution Control Agency, also have PFAS designated page. I know a few other states has that as well. So
Like someone else just shared a state regulation site where you can get that information. I can also share that after. Another question coming through for proportioning. Did you say proportioning test? Would you require a sample of foam concentrate, foam mixture, and system water sample to perform this testing? So 3 samples in total. Very good.
Yeah, that is correct. I mean, technically, we don't require that you provide the system water, but that would be the most representative sample to make standard solutions from. So I would recommend sending in all 3 tests. You don't necessarily, if you're just trying to do, you know, the foam mixture and figure out what the percentage of foam is in the mixture, you wouldn't necessarily have to have the concentrate tested. But we do need all 3 of those to do the proportioning test.
Okay, well, we're waiting for any last minute questions to come in. Thank you to all of our presenters today and our special guests. We really appreciate you guys sharing that information with us. We will be sending you a survey and appreciate your feedback, including any topics that you'd like to see in future webinars. We'll also send a link to the recording of this webinar. Our next webinar is scheduled for Wednesday, August 20th on antifreeze testing. There will be a link to register in my follow-up email. As always, watch the DINE website or our LinkedIn or Facebook pages and our monthly newsletter for more information. If you are not subscribing to our newsletter, there's a link at the bottom of our website. Feel free to click on that and subscribe. Thanks again for joining us, and we'll see you next time.